There are certain interesting numbers in mathematics like pi, e, etc. The numbers basically started with natural numbers. So 1 to infinity. Of course, infinity was not even conceived as a number, and so too was 0. So in the initial phases, and therefore we start with natural numbers, and then we move on to whole numbers, and then we move on to integers, the negative numbers. That itself is an interesting history on its own. Anyway, the point that I wanted to make is this number pi, which we refer to represent the ratio of circumference to the diameter, has a very interesting history. Why were they interested in calculating the value of pi to high degree? One way to see is, so it has to do with the area of circle, and you cannot avoid it. But then its nature was never understood. In fact, there are books which describe as the most mysterious number. And today we have understood that to be a transcendental number. So it was first recognized as irrational number, and the irrationality itself is not so easy to understand. So people struggled for thousands of years. And to have an exact representation of pi, so since it is irrational, it may not be possible for you unless you have infinite series in the right hand side. So any series that you have which adds up, if it is a terminating series, so it will turn into a rational number. So unless you have infinite series, there are various infinite series representations for pi. One interesting series which is today ascribed to Gregory and Leibniz is a series which was codified in the form of verse almost 300 years before Gregory and Leibniz by a mathematician called Madhava, as we understand today. Madhava was in 14th century. So these people have been in 17th century. So historically this is something which is not so well known. And if the series were to be given a name which actually honors the founder, so then it should be really called Madhava series instead of Gregory Leibniz series. This is a historical note about pi. What was the context in which people wanted to know the value of pi in the Indian tradition? If we look back, the kind of altars which people have been using thousands and thousands of years before for performing various rituals, every household was supposed to have 3 altars, one in the form of circle, the other in the form of square, and the third in the form of semicircle. So these were called as Tretagni. So one is called Ahavaniya, Dakshina, and Garhapatya. The constraint that people imposed was that the 3 altars should have the same area. Now you can very easily see as to why they wanted to know the value of pi. So it occurs in that context. So in the circle area, as you understand today, is pi r square, and that should be equated to sort of a square, and the area should be same. And we have some sort of approximation in the Shulva Sutras. Shulva Sutras, as I told you, so is around 800 BC. So we do not know exactly, because there is no reference which is found in Shulva Sutra which gives us a hint to make an estimate of the date of composition, as we find, for instance, in Aryabhatta or later works. Aryabhatta, for instance, gives a verse, so wherein he clearly states, see, Shashtyabdanam Shashtiryada Vyatitaha Trayascha Yugapadaha Tridhika Vimshatirabdaha Tadeha Mama Janmano Titaha. So he very clearly says the year of composition. And after Shulva Sutra, so we find a nice approximation for pi which has been given by Aryabhatta. Aryabhatta's verse goes like this: Chaturadhikam Shatam Ashtagunam Dvashashtis Tatha Sahasranam Ayutadvaya Vishkambhasya Asanno Vritta Parinaha. This is a very interesting verse. Interesting in the sense that it gives you a very clear picture that it has been clearly recognized by Aryabhatta that it is only approximate value. So how do we come to know? Because he has used the word asanna. Asanna means that which is close by. Asannaha vritta parinaha. How do they express? So they express the circumference on the left hand side in terms of diameter multiplied by some quantity. Okay. So this is how it goes. Chaturadhikam shatam ashtagunam. Chaturadhikam, so he basically gives you a ratio. Okay. So circumference should be mentioned in terms of diameter. So here he says, if this were the diameter, then you have to multiply by this term to get the circumference. Okay. So that is how he says. Ashtaguna means multiplied by 8. So Chaturadhikam shatam 104. So 4 above 100. Chaturadhikam shatam ashtagunam. Dvashashtis tatha sahasranam. Sahasranam dvashashtihi. Dvashashtihi is 62. So 62,000. 62,000 plus this. Okay. So it comes to 62,832. Ayutadvaya vishkambhasya. See, vishkambha is a term which is used for diameter as vistara, vishkambha, vyasa. These are the terms that they generally use for diameter. Ayutam is 10,000. Ayutadvaya is 20,000. Asanno vritta parinaha. Vritta parinaha, the circumference of a circle. So circumference of a circle is close to this. What does this boil to? So this boils to getting a value which is 3.1416 as the value of pi. So this is correct to 4 decimal places. In fact, people have been asking, so how did Aryabhatta get this value? So which is correct to 4 decimal places. What was the, so it is not something which one can draw and then keep measuring by something, some scale by which you will be able to get this kind of accuracy. It is almost impossible. So they had a way of doubling method. See, circumference doubling, you divide that into various parts and you can nicely get some formulae. So which essentially involves computing square root and square. See, so if you have a way, if you have the technique to find the square root correctly and the square, if you have algorithms for that, then you will keep on increasing your accuracy by taking more and more divisions on it. So that seems to be the polygon doubling method, seems to have been the method which should have been used even by Aryabhatta to get this value.